My name's Joel Gustafsson and I'm the engineer that's been working on the project's energy and sustainability strategy really from the early days in 2017 right through to planning and ongoing now as we move to deliver the site. From my perspective, it's been a fascinating project and a bit of a journey that we've been through with the college to define the energy strategy and utilise what is a great opportunity to improve environmental performance, energy performance and reduce environmental impact. The site gives opportunities across the board. So an energy strategy is boiled down to its basics, balancing demand for energy and the supply of that energy. So if you think about that's basically heat for buildings, that's basically heat and electricity. Demand is driven by moves that you can make for air tightness, insulation and strategic choices such as that. And then the supply is how you make heat, how you distribute it and any synergies that you can find. So one of the key steps here that was taken by the college back in 2017, I think there's a well-established principle of using a fabric-first approach to doing what you can with insulation, and indeed that has been undertaken. There are significant technical challenges with that, not least on the former URC, the church, where through detailed technical review and not wanting to put the fabric at risk, a lot of the insulation measures that were hoped to be delivered haven't been able to be. So the church is now on site, it's using a lot of heat and it's about a third of the site's heat demand. So a significant proportion, 120 kilowatts. Every other building is less challenging than the church, but certainly faces its own challenges. But what we've found is through the existing buildings, through measures like mechanical ventilation with heat recovery, internal wall insulation where possible, certainly improved glazing and air tightness, we've taken the heat demands down by circa 50% in those buildings. And in the new building in Dolby Court and the linear building, following basically best practice, exemplary practice for targets for insulation levels, air tightness, ventilation, has driven the demand of those buildings right down. So then there's the supply of heat. And in 2017, it was a strange place. We all see now and read the national press and indeed the trade press and regulations and the heat in building strategy and the Committee for Climate Change Net Zero plan. All of these things came out in 2019. There was a bit of a tipping point moment in the UK's approach to energy where we realised finally that electricity could be low carbon and was going to be low carbon and is projected reliably to continue decarbonising, which is a fantastic success story for the UK energy supply generally, but one that was missed within buildings for too long. And as you'll see from the length of time for this project, the decisions that are made in the early stages do get more and more challenging to kind of pare back upon. So following a very detailed review of fuel choice, gas or electricity, how to use electricity, etc., a bold decision was made to use heat pumps on the scheme. But not just that, that's not bold in and of itself. A lot of the earlier heat pump schemes have been a heat pump for a proportion of the heat and then a gas backup in case, it's really cold. Actually, what happens in that circumstance with two sources, they compete, and often we find across the industry that the low carbon heat source isn't being used as much as it should or is broken and that hasn't been realised and it isn't being fixed because there's the backup of the fossil fuels. This scheme is only using heat pumps. So there's risk associated with that. There's operational risk, there's resilience risk, and there's technical risk. Because since 2017, when that decision was made, the performance, the nature of refrigerants, the temperature regimes and the efficiencies are rapidly changing. But what that knowledge that there are only heat pumps on this site has driven very sensible decisions like allowing additional space in the West Court plant room that faces the university centre. And that has proved very, very useful when we've moved to reduce the noise impact of the heat pumps in that area through the detailed technical design. And so when completed, having a site of this nature with such diverse buildings, heritage buildings, a large church, new build low energy buildings, catering, screening rooms, educational spaces in 4 Mill Lane, only being served with a site-wide heating and cooling network will be precedent setting for college stock. And I mentioned cooling there, and it's important to come back to that. So there are certain uses that need cooling now, such as the basement rooms, and indeed with the classrooms with the noise from Mill Lane, to get a good level of acoustic comfort in the classrooms in 4 Mill Lane, we need to seal the windows, which puts a cooling demand onto the classrooms. For Dolby Court, a decision was taken that this is a long-term building with longevity in mind, so we have future climate change coming. We have the heat waves of 38.7 degrees when Cambridge set the UK's high temperature record. It's pretty uncomfortable. And so we have all of the passive design approaches which work now in 2021, allowing some level of overheating but still ultimately stay comfortable. So good glazing ratios, deep reveals, fixed shading where appropriate, high levels of secure ventilation, all of these passive design principles. We also can cool the soffit down, the concrete of the ceilings down, so that you get that kind of feeling of when you walk into a cold church on a summer's day and the fabric kind of happens, sort of takes the heat away from you and it's more comfortable. And so we're helping the passive design strategy by taking the heat out of those buildings. But it's not just being thrown into the atmosphere like most cooling systems, it's being brought back into the metabolism. So the heat pumps are heating and cooling heat pumps. So where there's excess heat in the system, like cooling the soffits in Dolby Court or the classrooms in 4 Mill Lane, it's brought back into the heat pump system, upgraded and put into the hot water tanks to be used in the showers and the catering. And so that closing of the metabolism helps to reduce the energy demand even further. We're using air source heat pumps rather than ground source. Ground was considered. Ground source is actually not that high yield in Cambridge. The ground's made of clay. It's very useful, it's great, but you need a lot of ground to produce heat at these sorts of quantities. And Dolby Court, attractive as it is, basically isn't enough heat to satisfy the church, the albeit improved 4 Mill Lane and 6 Mill Lane buildings. And so the moving air is a ubiquitous and almost limitless source of heat and is chosen really for that resilience and that reliability, as well as, for those that don't know, the Dolby Court is very heavily used for distribution and stormwater attenuation and lots of other stuff going on under the ground there. And so there's a nice generation of energy story here as well. So over the course of the project, PVs make electricity. They've improved their embodied carbon of the PVs themselves is decreasing rapidly. Their efficiencies are going up, and all of the roofs that face the right way, so east, west or south, are being used to generate electricity, which is certainly a useful way to offset the environmental impact of running the whole site. We've got an additional, a good story on water. So there's a large centralised rainwater harvesting tank going into phase 1, just near 4 Mill Lane, which will take all of the rainwater from phase 1 and give an underground store of that for irrigation. Before we get to using mains water to top it up, we're using a borehole. So much like the main site of Pembroke College, we're sinking a borehole to top up from the groundwater rather than taking the treated water from the main, which is coming under increasing pressure as Cambridge densifies and builds. There's a story here that's worth addressing, and people will look as Dolby Court is built and see the concrete, and concrete is getting people are becoming increasingly aware of the environmental impact of concrete. So there's a very, very long and thorough review undertaken by architects, structural engineers and ourselves to look at the impact of changing that concrete frame to a timber-based solution. In the end, it was chosen to retain the concrete frame for 2 reasons. One, there is an environmental impact and it is noticeable on this time frame, but the intent here is to respect that this is a long-term project for not just the college but Cambridge in general, and so that impact is spread. But more importantly, one thing that happens with buildings is that their usage changes. We see this if we look at the Mill Lane lecture theatres are being removed because that form is completely inflexible and the building is not able to be reworked into something usable for Pembroke College. But actually, what we're creating here with floor-to-ceiling heights and the depth of the plan could be used for all sorts of things, as long as there isn't too much structure in the way. So moving to a cross-laminated timber frame, for example, basically means that if you empty it all out, there's a lot of structure in the middle of each floor plate, which makes other uses, open plan uses, either offices or whatever it might be, gyms or other college facilities or non-college facilities, that much more difficult. And so the concrete frame is retained, flexibility is there, and I suspect fully that in 100 years it won't be student residential accommodation, it'll be something else. Case in point being the university centre, which is currently being completely reconfigured and revised by the university. There are inflexibilities in its concrete structure which are being worked around, but because there are large spans and not regimented and regular partitions, that it's taking in lecture use despite never being designed for that. So there are advantages in that hopefully mean that the scheme is highly performing, not just now when it's opened and decarbonising greatly all of the existing buildings, but also in the future as Pembroke College evolves and the wider city evolves into all the new uses. And yeah, I can see this being a jewel not just in Pembroke College's crown, but also something for Cambridge as a city to be very proud of.